Hello and welcome to this look at how to construct the dot-cross diagram for an unusual compound. So the one I'm going to use to show you the way I would work through it myself is sulfur dioxide, and then I'm going to apply the technique to a typical exam question afterwards. So the first thing to do is to go back to your periodic table and look at what group the elements are in. In this case, both of them happen to be in group 6. This means they'll each require 2 electrons to complete their respective outer shell when bonding. The second step is to consider the likely bonding type. Now, because they're both non-metals, from prior GCSE knowledge, you can assume you're using covalent bonding in your dot-cross diagram, which means the outer shells of the bonding atoms will overlap at the point where electrons are shared. And the next bit is to look at the ratio in the formula. So thinking about the number of electrons that need to be shared, it's going to be 2 per atom. In order for this to work, you're probably going to need double covalent bonds. So I'm going to propose a possible structure like that and use that to work from to create my dot-cross diagram. So remembering that each of these atoms will have 6 outer shell electrons already, that needs to go into the diagram in some way. And each of the double bonds means that there's 2 pairs of electrons being shared. So I'll come back to why I've drawn them at a slight angle in a moment. So what I normally do is start with the bonds. So the 2 double bonds I've decided are there, go in like that. So we've only used up 4 of its 6 electrons in sulfur's case, so it needs another 2. Now this creates what might look like a problem. We have 10 electrons in its outer shell. This is actually okay because it's something called expansion of the octet. I'll come back to this a little bit later, but sometimes larger atoms that you find in the p block, such as sulfur, phosphorus are common examples, and maybe some of the larger halogens like bromine or iodine, for example, they sometimes do this in order to create a stable molecule with covalent bonds. So we need to think about why atoms are bonding. Atoms are bonding to get stability. And by getting stability, they sometimes have to make adjustments. And in some cases, that means expanding the octet. So that means that instead of 8 electrons, you might have 10 or maybe even 12. The next thing to do is to look at the oxygen atoms. Now each oxygen has used up 2 of its 6 original outer shell electrons. So we need 2 lone pairs on each oxygen atom, like this. So this now gives us our final structure. Now, like I said, expansion of the octet is common in larger p block atoms, such as sulfur and phosphorus and some of the lower halogens. You don't need to go massively into it at A level, just accept that it happens. It's one of those slight quirks of the way atoms actually bond when you look at them in a more advanced way. So let's look at a typical A-level question. How might they ask this of you? So I've taken part of a question here, and they give you a structure, so they haven't asked you to work the structure out like we had to. But in the structure, you need to take note of what's going on, because there's several interesting features. So going back to the technique I used before, starting with the periodic table. Now the nitrogen atom is in group 5, so it's got 5 electrons already in its outer shell before it even gets involved in bonding. Those 2 oxygen atoms at the bottom are in group 6, so they have 6 electrons already in their outer shell. And this oxygen atom at the top, it is also in group 6, but because it carries a negative charge, there'll be an extra electron that needs to go on there. And that's where the different symbol for the extra electron comes in the question. I'm talking about this part of the question here. Quite often people forget things like that if they're told. And then finally, there's this arrow pointing from the nitrogen to the oxygen. That's your dative covalent bond. So that means that the 2 electrons in that bond both come from the N atom. So let's set up our basic structure here. We've got our atoms with the outer shell, no electrons in there yet. You've got the nitrogen in the middle. You're following the structure and you're overlapping the outer shells, leaving plenty of room to put in the electrons. So the first thing to do is to tackle the nitrogen. So I've put in the things that are in the question. I've got my double bond down here. I've got my dative covalent bond here. And I've got my normal covalent bond, single covalent bond at the top. So you need to also think about what does the X represent and what does the O represent. Now, because nitrogen is in group 5, like we've said, if you count up the number of X's I've used, 1, 2, 3, 4, and 5, I don't need to use any more X's anywhere. So the other electrons now will be the electrons that sit in the outer shells of the oxygen. So these will be non-bonding electrons. So remember, these were represented by a circle. So I've got to draw some of these circles in. So we need to draw in enough to add the oxygen up to 8, because like I said before, oxygen doesn't really do expansion of the octet. It doesn't really need to. So if we take each oxygen atom, you can see that they've got each has 8 outer electrons, and this is my additional one. I've gone to town a little bit and made it a different color, just to emphasize what I've done here. So what this represents is that negative charge. So let's have a look at what the mark scheme wants, and it's pretty similar to what we've done. Don't worry about charges or brackets or circles. They're not actually testing that out. What they're testing out is, can you arrange the electrons in the right way? They tell you to ignore inner shells because they didn't ask you to do inner shells, and you can rotate the diagram about a little bit if you wish. Okay, hopefully this has been a useful look at a slightly more tricky aspect of dot cross diagrams. As always, thanks for listening. Until next time, see you soon.